Hello and welcome to the presentation about our paper Towards a Holistic Data Preparation Tool by Michael Klettke, Uta Störl, and me, Valerie Rasted. I will first present the current challenges of data preprocessing, then I'll give a brief overview of the state-of-the-art of data preprocessing tools, and then I'd like to present the holistic data preparation tool we envision. The challenges of data preprocessing can be divided into parts. One of them are the workflow properties regarding the preprocessing process itself, and the other one is data quality regarding the results of this process. At first, we look at data quality. There is no single definition of what data quality means, but it is undisputed that it includes many different aspects and does not only concern accuracy. In an analysis of definitions from 1985 to 2009, several so-called data quality dimensions were identified with timeliness, currency, accuracy, and completeness, to name the most referenced. In another paper, a hierarchical data quality framework was built with the dimensions availability, which includes, among others, the aforementioned timeliness, usability, reliability, which includes, among others, the aforementioned accuracy, which of course is not the only aspect, but still a very important aspect. And there are different metrics, for example, precision and recall, and also integrity constraints or functional dependencies are important. The next dimension is relevance, with, for example, fairness, a very important aspect, which I will go into more detail next on, and presentation quality. Like I said, fairness is a very important aspect of data quality. The problem is the data often reflects some kind of biases or historical perceptions, and this problem is even amplified when output of biased algorithms is in turn used for further predictions. And in addition to a bias already present in the data, a bias can also be introduced into the data through preprocessing. An example for this would be a form that offers a binary gender choice, so you can specify if you're male or female. And if we now assume that about half of the attendees were male and half were female and some persons were non-binary, and if we also assume that women were more likely than men not to specify their gender, and of course the non-binary persons would also not specify their gender, then we would have some missing values. And if we now choose a mode imputation, where we impute the missing values with the most frequent value, which would be male, then we would skew the distribution and even exclude non-binary persons. These two different aspects of data quality. And next, we look at the workflow properties. In a survey with data analysis and infrastructure engineers, it was shown that data cleaning is time-consuming and needs human involvement, and that it is an iterative process with an ad hoc evaluation. So the analysts try different algorithms with different parameters, then look at the data. Does it seem right? Does it seem wrong? Then maybe adapt the algorithms. So this results in this iterative process. In an analysis of data cleaning tools, it was shown that there is no single dominant tool which includes all the different error types that exist. There have been some improvement with the holistic multi-tool strategy and with domain-specific tools, but overall it was stated that human involvement is necessary and that there is a lack of intelligent solutions. This was also stated in another survey of data cleaning tools, that human involvement is necessary, both IT and domain knowledge, and that there is a lack of intelligent solutions, and also that most tools already require like a pre-processed version of the data set, for example, with specific headers or specific delimiters. With regard to big data, there are two main challenges. The first one is volume. Because of the ever-increasing amount of data, the data quality gets compromised, and many data cleaning tools do not scale sufficiently. And the other one is variety, because of the diverse data formats and the different error types that exist. Another important aspect is reproducibility, and the iterative nature of data preprocessing brings further challenges for reproducibility, and the data alone is not sufficient. So it's not sufficient only to have the raw data and already preprocessed data, but there's a need to understand the data lineage. And reproducibility of data preprocessing in particular has so far received little attention compared to other areas. Next, we'll have a brief look at the state-of-the-art of data preprocessing tools. There are different tools and systems, but none of these systems can be considered a holistic tool, either because they only focus on a certain aspect of data cleaning, like error detection, or only on certain types of errors, like integrity constraints. Then IT knowledge is partly necessary in addition to domain knowledge, and the evaluation was mostly done on only one or few aspects of data quality, mainly accuracy. For example, fairness was mostly not considered. And most tools were only suitable for tabular data, so semi-structured and unstructured data was also not considered. In line with the aforementioned challenges, we now propose a holistic data preparation tool and would like to highlight some tasks that we think need to be addressed in future work. We look at them step by step, beginning with ensuring fairness. For a bias already present in the data, a tool like this should have support for extensive testing for different fairness metrics, and for a bias arising during pre-processing, the data changes and data distributions need to be measured. The consumer labels are conceivable here. If we think at the example with the mode imputation, that could be like a warning. With this strategy, we maybe skew the distribution. Of course, fairness is not the only aspect of data quality, so we think a tool like this should have a comprehensive integrated evaluation regarding all the different aspects of data quality, for example, through automated checks regarding to the arrival time, or to intervals of the data, or to the range of the data, or accepted values, then with different metrics, like I said, precision, recall, integrity constraints, functional dependencies, and with standards and specifications, and also consumer labels are conceivable. And next, we look at the workflow properties. Like I said, human involvement is still necessary. Many tools are used by domain experts without in-depth IT knowledge, so we think there should be an abstraction from IT knowledge. Different approaches are conceivable, for example, visual and interactive approaches, or approaches based on natural language processing, for example-oriented approaches comparable to query by example. Still, human involvement is time-consuming, so it should be minimized, for example, with the usage of machine learning techniques that automatically configure the data pre-processing pipeline, comparable to automatic DBMS tuning, or with the usage of dictionaries or knowledge stores. Another important aspect is reproducibility. Like I said, the data alone is not sufficient, but there is a need to document the whole pre-processing process and provide a description which algorithms were used, which parameters were applied. And this will be one of our next research questions we want to focus on, how this can be achieved in the best way. With regard to big data, there were two main challenges. The first one was volume. Because of the increasing amount of data, tools need to be scalable. And the other one is variety. Like I said, most tools are only suitable for relational data, or tabular data. So the quality of semi-structured and unstructured data needs to be better explored. And this will also be one of our next research questions we want to analyze. Like I said, we envision all these different aspects to be combined in a holistic data preparation tool. And as a basis for this, we implemented Gouda for the generation of universal data sets. We have encountered the problem that data sets are either not publicly available, or that ground truth is missing, or that they include only a few different error types at low error rates, which complicates a comprehensive analysis. And therefore, we implemented a test data generator called Gouda. With Gouda, we can generate data with diverse error types at arbitrary error rates. We provide a ground truth, and we made this publicly available so that it can be used for testing and extensive analysis. So in this presentation, we presented the holistic data preparation tool we envision and many requirements and possible solutions for the two categories, data quality and workflow properties. We presented Gouda, the test data generator we will use for our next analysis regarding the topics of the data quality of semi-structured and unstructured data, and data lineage and reproducibility. That's it. Thank you for your attention.